towards the typical world of investments and risk management finance, where the concept of probability can be applied. So, just as a quick agenda to understand this topic, initially for a few minutes we would be discussing on different concepts relating to the probability, right from the definitions of the probability to the different key terms that we talk in terms of probabilities, the conditional probabilities, the mutually exclusive, the independence, the joint probabilities, various rules relating to the probability, the addition rule, the multiplication rule, few important concepts relating to the probability. Then, using the probability, how I can go ahead in terms of computing the expected values, variance, standard deviations, etc. And that again takes me to the world of portfolio management. How can I use this concept of expected value and variance for computing the mean return and the variance of the returns of the portfolio? So I would be discussing about it. And towards the end, the two key areas involving probability, one is a Bayes formula, or sometimes called as a Bayes theorem, which is one of the revolutions in the world of probability, which we would be looking at. And finally the principles of counting, where we would be discussing something about the permutations, combinations, and the applications corresponding to that. So these are the different things that we are going to look at in this session. Having said that, see, initially, just to understand a few basic concepts of probability. First of all, the word probability comes from the uncertainty, or probably the randomness. Right? Probability is chance, probability is uncertainty, probability is randomness in the outcome. So wherever I am seeing that my possible outcomes, that the outcome that I am going to get out of my experiment, it is going to be random in nature. I am not sure what is going to be the outcome. I'm thinking that it is more random in nature. All those kind of scenarios come under the scope of probability. So any variable which takes random outcomes is called as a random variable. Right? Probably when I'm looking at the investment world, the daily return on a stock, I can treat it as a random variable, because tomorrow's return, I'm not sure how much I'm going to get. There could be a gain of 2%, there could be a loss of 2%, there could be a gain of 5%, there could be no profit, no loss. I'm not sure what all possibilities are going to be there. But in some cases, at least let's say when I'm throwing a dice, what value is going to come up on the top of the dice, I'm not sure. Even that is random. But what is happening is there are only a few possibilities that can come up there. Either 1, 2, 3, 4, 5, 6. But in this case, the possible outcomes are almost infinite in number. I can get almost any number as a return, as a percentage change over the previous period. But in both the cases, the outcome is random in nature, and any of the possible values are going to come. So any variable which we are looking at, whose value is going to be random in nature, or which is going to have an uncertain value, those all are called as random variables. So modeling of the random variables and understanding of the random variables is an important aspect in the journey towards understanding probability. Now each of these random variables can have different outcomes. So these are called as outcomes. So 1, 2, 3, 4, 5, 6 are here 2%, minus 2%. They are different kinds of outcomes. So whatever the value that a random number can take, or on today what did it take, that is an outcome. What came out of the experiment for today, those are the outcomes. And sometimes I may be more interested in looking at what is the chance of occurrence. When I am looking at probability, I am more focused on what is the chance of occurrence of a single outcome. So what is the chance that I get a 6 when I throw a dice, or what is the chance I get a 5% return tomorrow. So it could be a single outcome or it could be a series of outcomes. So what is the chance that I get a return greater than 2% tomorrow? So it's a series, 2, 2.5, 2.1, 2.2, 2.3, all of them come under the greater than 2% scenario. There are many possible outcomes that are coming into this particular scenario. Whereas when I am looking at the dice case, the possibilities are any one. So probably I can talk about a series of outcomes means what is the chance of getting an even number when I throw a dice. So that is what is associated with the event. So these are called as events, either a single outcome or a series of outcomes. All these, whatever is our interest, whatever is of interest as a part of our study, we are calling them as events. So any probability we try to find the probability of an event, probability of an occurrence of an event. So it could be a single outcome or it could be a series of outcomes, but we enter into the computation of the probability associated with the event, probability of getting an odd number, probability of getting a return greater than 2%. So all these are different events. Alright. So in some cases what could happen is the events whatever we have selected, or the event whatever I want to monitor, let's say I am taking two different sets of events which I would like to monitor. One is the event A, which says the probability of getting an odd number on the dice. When I throw a dice, what is the chance that I get an odd number? Whereas on the other side, I am looking at an event B, which says what is the probability of getting an even number on the dice. Now, if I look at these two events specifically, if this event is occurring, this event has no chance to occur. Because if the outcome that is coming to me is an odd number, it cannot be an even number at that point in time. Or vice versa. If it is an even number, it cannot be an odd. So whenever I am looking at two or more different events, when the chance of occurring of the first event or the event A, if the event A has occurred, event B cannot occur, and vice versa. Then I say that events A and B are mutually exclusive. If one event occurs, the other cannot occur. But on the other side, if I am saying A is an event which is getting an even number, B is an event which is getting a number greater than 4. Now these two are not mutually exclusive, because if 6 is the number that is coming, it is even as well as it is greater than 4. So if the event A has occurred, event B also might occur. So whenever I am looking at two events, if the situation is the event A occurs, the event B cannot occur or vice versa, then we call those two events as mutually exclusive events. So when I throw a dice, I am looking at events of getting 1, 2, 3, 4, 5 and 6. So the events, if I am taking them as 6 different events, all 6 are mutually exclusive, because if 1 occurs, 2 cannot occur, 3 cannot occur, 4 cannot occur, 5 or 6. So they become mutually exclusive events. And in case I am able to list out all possible outcomes, if as a part of the events, if I am seeing that all possible outcomes are going to come, then all those events together are called as exhaustive events. When I am taking a set of exhaustive events, what I mean by them is, in one event or the other, I see that all the outcomes are coming up. I see that all the outcomes are coming up in some form or the other. Probably if I am saying A is an event getting an even number, B is an event getting a number greater than 4, C is an event getting an odd number less than 4. Now what is happening? If I am looking at A as an event, the possibilities are 2, 4, 6. If I am looking at B as an event, the possibilities are 5 and 6. If I am looking at C as an event, the possibilities are 1 and 3. If I combine all 3, I know that all possible values 1, 2, 3, 4, 5, 6 are coming out. So A, B, C together are called as exhaustive events. Right? A, B, C together are called as exhaustive events. Probably B and C are mutually exclusive, because wherever B is occurring, C cannot occur. I can say A and C are mutually exclusive, because when A occurs, there is no way C can occur. But A and B are not mutually exclusive, because there is some kind of a commonality between them. So this is how the different kinds of definitions and the basic introduction to the world of probability comes up. Having defined this, any probability that I talk of, probabilities generally I find for an event, which I look at as the chance of the occurrence of the event. The chance of occurrence of an event. This is actually a number. Anytime we define probability, which is a chance of occurrence of a particular event, it's actually a number which lies between 0 to 1. 0 is also inclusive and 1 is also inclusive. The probability of occurrence of an event lies between 0 and 1. So if it is 0, it means that the chance of occurrence of it is 0, which means it is a never occurring kind of an event. Never occurs. Whereas when I am saying the probability of an event is 1, then it is called as an definite event. It can occur always. It occurs always means there is no randomness associated with that particular event. But in most of the regular practical cases, we see that the probability is going to lie between 0 and 1. So that's one important thing that we need to understand. And one more important point is, if I am bringing in